I want to take some time to talk about thermistor temperature sensors. They're two-wire sensors that change resistance with temperature. They're said to have a negative temperature coefficient. The resistance starts off high when they're cold and goes to a lower value when they heat up. Now, example are engine coolant temperature sensors, air charge temperature sensors, transmission oil temperature sensors, intake air temperature sensors, and we even have some vehicles have battery temperature sensors. Let's talk about what we're going to be looking at here and how we would test them. We have a very simple program. We simply say, go in here and do an open circuit test. Take it off. What we're looking for is if the tan wire, in this case, pin B out there on the intake air temperature sensor, can we see 4.9 to 5.1 volts open circuit in relation to ground? If we can, that tells us we have good wiring from the computer all the way out to the sensor. Remember, this is 10 or 12 feet of wiring. Then we're going to take a jumper and we're going to hook A into B outside and see if we do that, if we can see 0 volts. Because we're going to hook sensor ground right back around to C250 at the computer and see if it can pull down. If we do, we have good sensor ground, we have good wiring, and it gets all the way back to the computer, and the computer can read it accurately. Now that's our 1, 2, 3 quick test. Then we put the sensor back in, and we're going to see what it reads. We know that the wiring in the computer is good now. When we start this test, we take a Raytec heater gun, and we say, wow, we're reading 68 degrees Fahrenheit. At 68 degrees Fahrenheit, we should be reading 4 volts. If that's wrong, we know it's absolutely positively the temperature sensor. Let me say it again. We qualified the wiring for the signal, the wiring for the ground. So we know sensor ground is good. We know the wiring gets all the way back to the intake air temperature signal. The computer reads it accurately. We put the sensor on. If the sensor doesn't read absolutely accurate, it's a bad sensor. Simple, basic diagnostics. Works well. Some people want to measure resistance. Well, that's have to get in there and do that. If I measure resistance of the sensor, that doesn't tell me the circuit's good or bad. I have no idea what the circuit is. If I use voltage, I know what I've got. I know what I should have. We can start off and say, look, let's look and see if this drops straight down in a linear fashion as we heat it up. Now, voltage is high at low temperature. And if we use a slow trace on our scope, it'll slowly come down. At high temperature, it'll be low voltage. But it doesn't always do what we think it's going to do because Chrysler and some GMs use dual range temperature circuits with parallel circuits inside. Notice we have a 1,000 ohms resistor with a switching transistor in the bottom of it. We can turn on for high temperature readings. And then a low temperature reading of 10,000 ohms. Some people say, wow, don't you worry about that 10,000 ohms being in parallel to the 1,000? No, because when we turn the 1,000 ohm, it's so low that the 10,000 looks like it's not even in the circuit. When you have a 10-to-1 ratio, you only see the 1,000 ohms. It's very small difference. Here we are. We turn the transistor off, put the 10K ohm resistor internally. We drop the high voltage down, somewhere midway, 140 degrees or so. We switch over. We put the 1,000, 1K ohm internal resistor in. The voltage goes back up and goes back down. What this does is give us much better definition of the high temperature range on the coolant sensor. We can read high temperature much more accurately with a dual ranging system than we can before. We can see this with a lab scope. So basically, it's a real simple circuit. We do our 1, 2, 3 quick tests. Can we get 5 volts out there? Can we get 0 volts back? Yes. Plug the sensor in. Can it accurately show us what the actual temperature is? If it doesn't, it's a bad sensor. Keep it simple. It works well.